integers. Integers are positive and negative whole numbers. Examples are plus or negative 1, 0, plus or negative 7. Now rational numbers. Numbers that we can write in the form a over b, where b is not equal to 0. And we have a and b integers are what we refer to as rational numbers. Examples are 0. We can write 0 as 0 over any number. So this is an integer and this is also an integer. 1 over 2 is an integer, this is also an integer. So 4 can also be written as 4 over 1. Now all terminating and recurring decimals are also rational numbers because we can write them in the form a over b, where both of them are integers. Now non-examples of rational numbers. 1 over root 2 is not a rational number because this is an integer, but this is not an integer. This is an irrational number, or it's an example of a set. Sets. When we take the square root of some numbers, like these numbers, and we evaluate them, we get some values that are not exact. They do not repeat also. They are irrational. These are what we call the square root of non-perfect squares, and they are all examples of sets. So all these are examples of sets. But there are some numbers that are perfect squares. When we take their square roots, we get exact values. So these are not sets. All these are not examples of sets. We can add or subtract two or more sets. So if you have two sets, m root a plus n root a, we can add to get m plus n root a, and the same thing applies to the subtraction also. Now know that the a is always positive. Now let's look at the properties of sets. Root a times root a will be equal to root a squared, which will give us a. And root a times root b will give us the square root of a times b. Then also root a divided by root b will be equal to root of a over b. So for all this, a, b must be greater than 0. If we have constants multiplying the sets, then those constants must multiply outside a set. And we apply the same property, that is root a times root b. So the sets will multiply and the constant will also multiply. If they are dividing and we have constants multiplying, the constant will divide and the set will also divide. And the same condition holds again. Rationalization of sets. If we have set in the denominator, then we can remove the set from the denominator by rationalizing it, meaning that we multiply both the numerator and the denominator by root a. We have not changed anything. Then we simplify using the laws or the properties of sets to obtain m root a over a. So when we rationalize m over root a, we get m root a over a. If root 2 plus root 3 over root 3 is simplified as m plus n root 6, find the value of m plus n. So we share the denominator for them, so we are going to get root 2 over root 3. root 2 over root 3 plus root 3 over root 3. Now we know root 3 over root 3 will give us 1, so we are going to get 1 plus root 2 over root 3. Now you have to rationalize this, so we multiply by root 3 over root 3, and this will further give us 1 plus root 2 times 3 all over root 3 all squared. Root 3 all squared. So we can simplify this further to obtain 1 plus 1 over 6, 1 over 3, 1 over 3 root 6. 1 over 3 root 6. Now when we compare this to this, we are going to get m to be equal to 1, our m to be equal to 1, and our n to be equal to 1 over 3. Now we find our m plus n. So the m plus n will now be equal to 1 plus 1 over 3. And this will give us one whole number, 1 over 3. Now the next example, we are finding k in root 50 minus k root 8 over 2 root 2. Now we need to multiply 2 by root 2, so we have root 2 times root 50 minus root 2 times root 2 times k root 8, root 2 times k root 8, then is equal to root 2 times k root 8 is equal to 2 root 2 times 2 over root 2. Now we simplify this further to obtain 2 times 50, which is root 100, root 2 times 50, root 2 times 50, and minus k root 2 times 16, k root 2 times 8 rather, is equal to 2. Now we simplify further to obtain root 100 minus k root 4, then root 16 rather, and this will be equal to 2. So this will give us 10 minus k times 4. K times 4 is equal to 2. Now we simplify further to obtain 4k. To obtain 8 is equal to 4k. So we divide both sides by 4 to obtain our k to be equal to 2. Hence the correct answer is D. Now let's simplify this. We are going to get 5 over root 3 minus 3 over root 2. So what we do is we rationalize each of them. So rationalize 5 over root 3 to get root 3 over here, then times root 2 over here. Now we proceed to obtain 5 root 3 over 3, and this one will give us 3 root 2 over 2. Then we collect our LCM to be 6. Now this will go here, 2 times 5 will give us 10 root 3, then this will give us 3 times 3 will give us 9 root 2. Now we simplify to obtain 1 over 6 10 root 3 minus 9. So 1 over 6 10 root 3 minus 9 root 2. So the correct answer is D. Now let's look at, we are simplifying 20 over 5 root 28 minus 2 root 63. So we simplify each of the sets. They are reducible sets, so we are going to get 20 all over 5 into bracket 7 times 4, 7 times 2 all over 2 into bracket 9 times 7. Then this will give us 20 all over this is rather supposed to be 4, so 20 all over 5 times root 4 root 7. 4 5 root 4 root 7, then minus 2 root 9 root 7, minus 2 root 9 root 7. Then we simplify further to obtain 20 over 5 times 2 into root 7, then minus 2 times 3 into root 7. Then we continue further to obtain 20 over, this will give us 10 root 7, 10 root 7 minus 6 root 7. Now we'll simplify further to obtain 20 over 4 root 7. Now this will give us 5 over root 7. So we need to rationalize 5 over root 7 to obtain, so we are rationalizing 5 over root 7, and this will give us root 7 over root 7. So this will give us 5 root 7 over 7. Now the correct answer now. So in short, you need to master how to use the properties of sets, and also when sets are given to you, make sure you try to see whether they can be reduced before you continue to add them or subtract them.